Hey everyone, and welcome. You know those awesome Android apps you use every day? Well, there's a really good chance they're built with a language called Kotlin. And today, in just the next few minutes, we're going to skip all the boring stuff and dive right into the code. We'll write our first program, figure out how variables work, mess with some logic, and even check out one of Kotlin's absolute game-changing features, null safety. So you ready? Let's do this. Look, the best way to learn a new language isn't by reading a textbook, right? It's by actually speaking it. Or in our case, by writing it. So let's get our hands dirty. All right, Section 1, your first Kotlin program. We are not wasting any time. Let's jump right in. Okay, getting started is really just a simple three-step process. First, you got to open up your coding environment. A lot of folks use what's called a REPL. Now, don't let the acronym scare you. Think of it like a direct chat with Kotlin. You type something, hit enter, and bam, it responds instantly. It's awesome for learning because you get that immediate feedback. And there you go. You've just written a real program. Seriously, take a look at how clean and simple that is. The keyword fun just means function. And print line, well, it does exactly what you think it does. It prints a line. So simple, so readable. That's really the whole vibe with Kotlin. Okay, so we got the computer to talk. Awesome. But what about making it remember stuff, so we can use it later? Well, that's where variables, types, and operators come into play. These are pretty much the Legos of programming. This is a super important concept in Kotlin, so lean in for a second. We have var and val. Think of var like a box where you can swap out the contents anytime you want. But val is like a box that's been sealed shut. Once you put something in it, that's it. It's permanent. Now here's the pro tip. Developers almost always try to use val. Why? Because it makes your code way safer. If you know a value can't possibly change by accident, you just wiped out a whole bunch of potential bugs before they can even happen. Okay, let's talk about the basic flavors of data you'll be using. You've got your whole numbers, which we call int, your decimal numbers, or double. Then you have your simple Boolean for true or false, and of course, string for any kind of text. But here's the really cool part about Kotlin. You usually don't even have to tell it what type you're using. It's smart enough to just look at the data and go, oh, that's a number, or yep, that's text. It's called type inference, and it saves you a ton of typing. And of course, we can do math. All the basic operators, plus, minus, multiply, divide, they all work just like you'd expect from your math class. But pay attention to this, because it's a classic rookie mistake. See how dividing 50 by 10 gives you a whole number, 5? But when we use numbers with decimals like 2.0 and 3.5, we get a decimal back. This is so important. Forgetting this is how you end up with a program that says something costs $7 when it should be $7.50. The type of number you use completely changes the result. Oh, you are going to love this feature. It's called string templates, and it makes working with text so much cleaner. You know how in some languages you have to do all this clunky plus sign stuff to combine text and variables? Not in Kotlin. You just stick a $sign right in front of your variable, right inside the string. And if you need to do a quick calculation, just wrap it in these curly braces. It's one of those small things that makes your code so much more pleasant to read. All right, so our program can remember stuff and do math. That's a great start. But a program isn't very useful if it just does the same thing every single time, right? We need it to be smart to make decisions. And that's exactly what control flow is all about. And here it is, the classic if-else statement. This is probably the most common way to make a decision in any programming language. It's literally a fork in the road for your code. The program looks at the question in the parentheses. In this case, are there fewer than 20 guests? If the answer is yes, it goes down one path. If the answer is no, it goes down the other path. Simple as that. It's your program's way of choosing its own adventure. So, what's the output going to be? Well, since we had 30 guests, the check for less than 20 was false. So the code completely skips that first part and jumps right down to the else block printing large group. See? It's perfectly logical and predictable. Now, if-else is perfect for a simple yes-no choice. But what if you have like 5 or 10 different options? Chaining a bunch of if-else statements together gets really ugly really fast. That's why Kotlin has something way better, the when statement. It's basically a superpowered if. You can just give it a value and then list out all the possible cases and what to do for each one. It's so much cleaner and easier to read. Okay, so far we've only dealt with one piece of data at a time, right?
a single number, a single name. But in the real world, you're usually working with groups of things, a list of songs in a playlist, a bunch of contacts in your phone. So let's see how Kotlin handles collections of data.
So the two big players here are lists and arrays. And the main difference between them really comes down to one word: flexibility. A mutable list is like your grocery list. You can add stuff, cross stuff off, it can change size. An array, though, is more like an egg carton. It's built to hold a specific number of things, say 12 eggs, and that size never changes. So if you need something that can grow or shrink, a list is your best friend. If you know the size is fixed, an array is super efficient.
And actually making them is dead simple. List of creates a list that you can't change later on. It's read-only. And array of makes that fixed size container we just talked about. The syntax is super clean, which is a running theme in Kotlin. The language tries to get out of your way so you can just focus on your actual idea.
All right, buckle up. We're about to talk about what might be the single most famous and most loved feature in all of Kotlin. This is a built-in safety net that literally prevents one of the most annoying, crash-inducing bugs that has plagued programmers for decades. I'm talking about the dreaded null pointer exception. It's been called the billion-dollar mistake because of how many crashes and bugs it's caused. See, in most other languages, any variable can secretly be null, which means it holds nothing. And if you try to use it, your app just crashes. But Kotlin's approach is genius. It flips the whole idea on its head. By default, nothing in Kotlin is allowed to be null. Period. The compiler itself acts like a bouncer and just won't let it happen. But you might be thinking, wait, sometimes I actually need a value to be optional or missing. And you're right. Kotlin's solution is so simple and elegant. You just add a question mark to the type. That little question mark is you, the programmer, telling the compiler, hey, I'm aware this might be null, and I'm taking responsibility for handling it. It forces you to think about it up front, which is so much better than finding a crash later. And to help you handle these maybe null values, Kotlin gives you some awesome tools. First, there's the safe call operator, which is just a question mark and a dot. It basically means, try to do this, but only if the thing isn't null. If it is null, just don't worry about it. Do nothing. No crash. Then there's my personal favorite, the Elvis operator. And yes, it's literally named after Elvis's hairstyle. It lets you provide a fallback value. It's like saying, I want to use this variable, but if it happens to be null, use this other default value instead. It just makes your code so much safer and more concise. All right, let's take a breath and just recap what we've done. In just a handful of minutes, you've seen how to write your first function, how to store data using var and val, how to make your code smart with if/else, how to handle groups of data with lists and arrays, and you've gotten a taste of Kotlin's incredible null safety system. That is a ton of ground to cover. Seriously, well done. And that brings us to the most important question of all. You now have the absolute basic building blocks for a really modern and powerful language. So the only thing left to ask is, what are you going to build with it? The next step is all yours. Thanks so much for hanging out with me on this whirlwind tour of Kotlin.